Hello everyone, I am Suvrat Mehta. Today we will be discussing CodeChef Starters 204. So, uh, let's start with the discussion. Problem A. Alice and Bob are playing a tournament which consists of N matches. Right now, they have completed M matches already, and you have the results from those matches. You are given a binary string S of length M, where Si is equal to 1 means that Alice won the ith match, and Si is equal to 0 if Bob won the ith match. At the end, whoever has won more matches wins the tournament. However, if both of them win equal number of matches, the tournament ends in a tie instead. Given the matches that have already been played, is it still possible for the tournament to end in a tie? Print yes if it is possible and no otherwise. So each test case consists of multiple lines of input. The first line of each test case contains two integers n and m, the number of total matches to play and the matches already played. The second line contains a binary string s. So problem A. Basically, we are given n comma m and a binary string s. N is the total number of matches and m is the number of matches already played, and s is the outcome of m matches. Outcomes of m matches. Basically 0 if Bob win, 1 if Alice won. We need to tell if the tournament can be drawn or not. So let's see the test cases. The first test case is 2210, 22 and 10. So basically, out of two matches, both the two matches have already been played, and the outcome is 1-0. So Alice won one match, and Bob also won one match. So yes, this can be drawn. So basically, the answer would be yes. The next test case is 43111, 111. So Alice has won three matches, and Bob has won zero matches. And basically 4 minus 3, 1 match is remaining. So no matter what is the outcome of this last match, Alice and Bob will never have same numbers of wins. So the for this test case is no. The next test case is 3210. So basically Alice has won one match and Bob has won zero matches. Bob has also won one match, and 3 minus 2 equal to one match remaining. So basically, since it is draw up till now and there is only one match remaining, so whoever wins this last match will win the tournament. So again, it is impossible to draw this. Then 6500100, again impossible to draw because four matches Bob has already won and only one has been won by Alice, and there is only one match remaining. The last test case, 640001. 640001. So basically, Alice has won one match, Bob has won three match, and n minus 6 minus 4 equal to two match remaining. So if both of these matches are won by Alice, then yes, it can be drawn. So basically, uh, using the string S, we can calculate the number of matches won by Alice. And similarly, B is equal to number of matches won by Bob. So, and left will be the n minus m, basically leftover matches. And absolute of A minus B would be the difference between number of wins in Alice and Bob. So basically, if absolute of A minus B is less than left, is greater than left, so the difference between the wins of A and B is greater than the number of matches left. So that means in no case the outcome will be a draw. Since even if the person having less wins wins all of the remaining matches, still he will have less number of wins in the end. So the answer will be no in this case. But if absolute of A minus B, so if this is greater than lift, so no. If it is less than left, so basically left minus absolute of A minus B would be the number of matches that will be played after the score of A and B are equalized. So basically, let's say A has 3 score, B has 7 score, and the number of matches left are 10. So obviously, to draw, both of the teams should have same number of wins. So let's say out of 10, the first 4 matches are won by Alice, so that 3 plus 4 would be equal to 7. So basically, after first 4 matches, A would be 7 and B would be 7 and left would be equal to 6. So basically, left minus absolute of A minus B is the leftover matches after we have made the scores equal. And if this is even, then yes, else no. So basically, this is if, else no. So why even? Basically, here in this case, there are 6 matches left. So what we can do, we can do a distribution like this. So Alice will be winning 3 and Bob will be winning 3, and in the end, both of them will have a score of 10-10. So this is a draw. So basically, this was the logic for the question. This. So this can be implemented in O of M, since we need to just traverse once on the string S to calculate A and B, and the rest of the operations are O of 1. So basically this is O of N solution. I'll show you guys the code. So LLNM and then string S and then A and B. Using the string S, I'll calculate the number of wins of Alice and Bob. Left is the number of matches left and difference is the difference between A and B. So if left is less than difference, then simply no. If left minus difference %2 is 0, then yes, else no. So this was the solution for problem A. Let's move on to the next problem. So minimize sum. You have an array A of n integers and an integer m such that 0 is less than equal to AI is less than m. You can do the following operation as many times as you want. Set AI equal to AI plus 1 mod m for all indices I1 is less than equal to I is less than equal to n. Find the minimum possible sum of the array A after doing the above operation some number of times. So basically, we are given an array A. Just problem B. We are given an array A with elements A1, A2, AN. and we can perform the operation. We can set AI to AI plus 1 percentage mod. So this is AI for all I belongs to 1 to n. So we can set this, and after performing these operations as many times as we want, what is the minimum sum? Minimum sum of the array. So basically, in mathematical terms, we are just asked to minimize this summation I is equal to 1 to n ai plus t more percentage m for some t, for t belongs to all integers, positive integers. And what is the minimum of this for t belongs to positive integers? And this is our answer. So let's see the constraints. So the constraints are n and m are till 2e5 and ai is greater than equal to 0 and less than m. The sum of n and the sum of m both do not exceed 2e5 over all test cases. So basically expected time complexity would be around n or n log n. So let's see the test cases now. Let's see this test case. N equal to 4, m equal to 10 and 2917. So basically initially the sum is 2 plus 9 11 12 and 12 plus 7 19. Let's try to increment each. So this will become 3, since 3 mod 10 is 3. 9 plus 1 10, 10 mod 10 is 0. 1 plus 1 2, 9 8 7 plus 1 8. So the sum here would be 5 and 13. So here the sum decreased. So next 4 1 3 9. So here it will become 17. Next is 5240. The sum becomes 911. Here also decreased. Then 6351. Then 7462. Then 8573. So here the sum is 15. Here the sum is 19. Here the sum is 23. So 9684 and then 0795. So basically here 27, 21. So here also decreased. And then again 1806 2917. So here it is 1415 decreased, and here it is 11 12 19. So these two are exactly same to each other. And why is that? Also, basically, we added plus one, 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 and another plus one. So basically, we added it 10 times, and m was also equal to 10. And we got the same exact array in the end. So basically, uh, in this summation I plus t mod m, um, we need to only check for values 0 t less than m, since after this the same values will repeat. Since if t equal to 1, t equal to m, then the summation will simply become ai plus 0 mod m. So it is the same as when t was equal to 0. And if t was tm plus 1, then this will become 1 and it is same as t equal to 1. So basically, we only need to check for 0 till t till m. So this is the first observation. Then basically we also see one more thing, that the array decreases only at some specific points. And what did those specific points have in common? Basically, 9 was turned in 9 turned into 0, 9 turned into 0, 9 turned into 0, 9 turned into 0. Basically, other than this, the sum of the array never decreased. Why is that? So basically, the sum will only, this sum I equal to 1 till n, ai plus t, ai plus, for now, let's do 1, ai plus 1, percentage m. So this sum will be only less than equal to ai mod m. Basically, ai is given less than m, so no need for mod m. This sum will be only, let me just a second. How do I select it? Okay. Okay. So basically, I equal to 1 to n. So this will be only less than this only when at least value of 1 ai is decreased. ai is greater than equal to ai plus 1 mod m. This should be followed for at least 1 I. Only then this summation can be greater than this summation. Otherwise, all of the elements here will have a greater value here. So greater value corresponding to them here. So basically, then this cannot be greater than this. So this must be true for at least one value of I. So when will this be true? When ai plus 1 is equal to m, or ai is equal to m minus 1. So basically, value decreases only when some element turns into 0. So what we can do is, we see that each element turned 0 exactly once, and it gave us corresponding 4 different values, and the answer must be out of these 4 values only, because the rest of the values would be greater than them, because the answer is always increasing, but it decreases only at these points. So these 4 answer must be out of these 4 points. So since 11 is the smallest value here, 11 will be the answer, and we can see that 11 is the answer. So basically, another observation, an array might be an answer only when it has an element that turn to 0, or let's just say only when some element is 0. Because if it is 0, that must mean in the last iteration it was not 0, since ai plus 1, it was m minus 1. So basically the value decreased by m minus 1. So using this observation, let's try to find the answer. So what we can do is we can try to brute force. How? Basically find the value for when each element turns to 0, and then take the maximum of those, minimum of those, sorry. So basically what I'm saying is, in the array 2917, I know that for 2 to turn to 0, I will have to do plus 8, right? So I'll do plus 8, so this will turn to 10, this will turn to 9, 9 plus 8, 17, more 10, 7, this will turn to 9, this will turn to 5, and the array will have a sum of 17 and 14, 31. Oh, sorry, 21 actually. This is not 10, this is 0. Yep, you can see that here. Then I can see I can check for the answer when this element turns to 0. So basically that is plus 1, 3, 0, 2, 8, 11, 12, 13. And I can see for this element as well, plus 9. So 1, 8, 0, and 6, 14, 15. And plus 3. So 5, 2, 4, 0, which is 11. So this is our answer. So now instead of checking for so many different values, I only checked for 4 different values. So now instead of running, now to do this, basically the total time complexity would be n square, right? Because for each element I will need to find the what should I add to the array, and then I will need to add to the array that number and calculate the answer. So basically this would be O of n square. So we need to find some way to calculate for each number when it turns to 0, what is the answer. We need to try to find this in n log n. So basically some numbers, so let's sort the array. For this, let's sort the array. What does sorting the array do? Basically it lets us manage the numbers smaller and lesser. It lets us manage that pretty easily. You guys will see in a moment. So let's try to find the answer when 2 turns to 0. So that would be plus 8, right? So this has now turned to 0. I just need to calculate the sum of this and this, right? So basically, since 2 plus 8 is 10, all the numbers greater than 2 value will be greater than 10. And all the numbers lesser than 2 value will be less than 10. So basically, these numbers, they will transform into sum, the original sum plus 10 into whatever the count of these numbers is, x, let's say. and here the sum, original sum plus 10 into x, not 10 into x, 8 into x, plus 8 into x, here also plus 8 into x, and since after 8 into x all of the values become greater than 10, so they will be undergoing through the modulo 10, and basically these values, since ai is less than m, and we said that t needs to be only till m, actually less than m, so ai plus t will always be less than 2m. Hence, if we know that ai plus t is greater than m and less than 2m, so ai plus t mod m would be nothing but ai plus t minus m. So this will become sum plus 8 into x minus 10 into x. Actually not x, y. And x is the number of numbers smaller than 2 and y is the number of numbers larger than 2. Let me write that formally as well. So basically this was a straightforward solution. Also we can see that let's put the value for this case. So sum is 1 initially, 8 into 1 plus sum here is 16 initially plus 8 into 2 and minus 10 into 2. So this is 8 plus 1 plus 16 plus 16 minus 20. So 24, 25 minus 4, which is 21. And we can see that when 2 became 0, the value was 21. So our approach was correct. But now another issue is we don't have all the elements distinct. So there can be multiple same elements. And so there can be some 2's here and 2's here as well. So for the 2's here, we will be doing sum plus 8 into x, which is wrong. Because all these 2 would be transforming to zeros and all these 2's will be transforming to zeros. So what we need to do is we can now use a map to resolve this issue. So let's take some example. Let's just imagine a map. So basically map is like this. These are the values and their frequencies. So value and frequency. So now for each value, when it gets set to 0, I need to find what is the answer. And then for all the answers, I need to find the maximum answer, right? So let's say currently in this frequency, in this map, I am calculating for this element to be set to 0, right? For this particular element, x. Let's take it as a v and f. So v is its value and f is its frequency. So for this particular element, let's say that here the sum of all these elements, basically sum of value into frequency of all these elements, let it be s1, and just the sum of frequencies, let it be s2, s1f. And similarly here we have s2 and s2f, right? So for this particular v, the value would be basically all the elements smaller than v, which is s1 will be their sum, and then s1f would be their frequency, and since all of them will be added by what m minus v, so this will be the sum of all these elements, new sum of all these elements. And for all these elements, what we can do, S2 is their original sum, then S2F into m minus v, and then minus S2F into m. So basically, this will be our formula. And since we are iterating over the map, after finding out for this, we will move on to the next, and update laws will be like this. So when we move on to the next index in the map, so we will need to update the values of S1F, S1 and S2F and S2. So basically, this group will be added to S1 and this group will be removed from S2, right? So update will be like this. During at the end of each iteration, basically when we are finished calculating the answer for this, what we can do is S1F plus equal to F current and S1 plus equal to V into F. So that will make our S1 look like this and S2 is still this, right? So S2 is still this. So at the start, what we can do of each iteration, we can do S1F. Now at the start means I am currently calculating for this. So I am on this index only. So S1F, S2F minus equal to F and S2F minus equal to V into F. So basically this will change our S2 to this, and this will be the update that we will be doing, and answer would be the maximum of this. So the overall time complexity would be O of n log n, since we just need to create a map and follow this procedure. And also initially since we will be calculating for this element, so S1F is equal to 0, S1 is equal to 0 and S2 is equal to this much, right? So since we are at the starting removing the current box from S2, so S2 would be the total sum and S2F would be n, and then the first element's value and frequencies will be removed from S2F, and that's how it will get updated. So these will be the starting values, and this is the map of frequencies. So this is, and basically in a map the frequencies are always sorted, right? So all these would be greater than V and all these will be lesser than V. I used this fact to calculate this. So I'll show you guys the code for this now. So basically I take input vector V and then I create the map MF, and then initially S2 is the total sum, S2F is n, S1F is 0 and S1 is also 0. And answer initially is set at the total sum, which will be updated in the for loop. So in the for loop, at the start, S2F minus equal to F and S2F minus equal to V into F. So S2 minus equal to V into F, S2F minus equal to F. And the answer is this formula, S2 plus S2F into M minus V, S2 plus S2F into M minus V minus S2F into M minus S2F into M plus S1 plus S1F into M minus V plus S1F into M minus V plus S1 plus S1. So this is the formula, and we are taking the minimum of it, and then at the end S1F plus equal to F, S1F plus equal to F, S1 plus equal to val into frequency. So the operations on map are in log n, and so overall time complexity would be n log n. but also we could have created instead of a map, basically a vector, which the index I would tell the frequency of number I in the array. We could have done that, and then all the map operations would have been O of 1. So we can also write this in O of n as well. So, but anyways, O of n log n is good enough. So let's move on. This is the next question. So cities colors. You once again find yourself exploring the beautiful region of Sheffland. There are n cities in a row. Each city has a color preference of Ci and has a wealth of Wi. Initially, you are at a city 1 with a color of 0 and you have 0 points. For simplicity's sake, it is guaranteed that C1 equal to W1 equal to 0. Then you may perform any of the following operations. Set your color to any integer you wish. This reduces the amount of coins you have by k. Move from city I to city I plus 1. If your current color is the same as Ci plus 1, you will gain Wi plus 1 coins. Otherwise, you will lose Wi plus 1 coins. If you are at city N, your travel ends. Note that you can have a negative amount of coins at any time. What is the maximum number of coins you can end up with after this trip? So first line contains two integers n and k. The next line contains n integers w1 till wn and n integers c1 till cn. The constraints are n is till 2e5, k is till 1e9 and wi is also till 1e9, c is till n and c1 and w1 is 0. The sum of n over all test cases do not exceed 2e5. So the expected time complexity would be O of n or O of n log n. So problem C. So basically there are n cities, each with a preference. Mhm. Preference color Ci and a weight Wi. Weight, no, actually not weight, wealth Wi. And initially our color is C equal to 0. And what we can do is we can change our color to any other color by paying K coins. And if at any city we have the same color, then we get Wi coins, or else we lose Wi coins. So that was the problem C. Just a second, guys. I'll be back from washroom. So this is the problem C. So let's try some test cases. So let's try. Let's see this test case first. 0233 and 024011. So n equal to 3, k equal to 3, 024, 011. Let me just am I audible? Okay, I am audible. So 024011. So basically initially our color will be 0 and we are here. So what we can do is we can pay k coins to go to color 1 and our initially our balance, let me just write it down here, C and wealth, actually what exact word, points. So color and coins, initially 0 0. Then what we can do is we can pay k coins, so -3 and color 1. And since now we have color 1 and this city also has color 1, so we get +2 coins. And then we move on to the next city and again we both have the same color, so we get +4 coins, so 3. So hence 3 is the answer for this. No matter what other uh, ways you try, the maximum you will get is 3. Also, let's take this test case. 0 1 1 1 1 1 0 1 2 2 2 3. 0 1 1 1 1 1 0 1 2 2 2 3 and k is equal to 2. So initially coin color coins both 0 0 and then the next color is 1. So basically paying k coins to get the color 1 is worthless because we will be only getting 1 coin for that. So it's a loss. And either way, if we do actually pay k coins, so -2, and then the 1 coin you will earn, we will end up with a -1. And but if we don't actually change our color will remain 0 only, and we would still get a -1 because minus wi will be our score if the colors do not match. So what we can do on the next step, since we see that there are 3 2's, so we can buy the 2. So our score will get -3 and then 0 and then +1 for this. So basically -2 and color is also 2. -1 color is also 2, 0 color is also 2, and then again it will be -1 color is 3 or 0, 3 or 2. So answer for this test case is -1. Let's see the last test case. 5 15 0 11 12 13 14 0 11 12 13 14 0 3 2 1 4. So color and coins initially 0 0, and what we can do is we can switch to the color 3, then that would be -15 and +11, so -4. So getting a -4, there is no point in getting a -4, so let's just stay at, so either we if we stay at the same color we will be getting a -11, but instead if we switch to color 3 we will get a -4 and our color will be 3. So moving on to the next, we can either stay on color 3 or we can switch on color 2. So if we stay on color 3, we will get a -12. But if we switch on color 2, we will get only a -3. So color 2 and -4 -3, which is -7. Similarly, we will again switch to get -9 and then we will again switch to get -10. And this would be our answer. Because there is no better way possible. So -10. Now let us look at this test case 0 1 1 1 1000 and 0 1 0 1 2 3 1. So 0 1 let me scroll. N equal to 5, K equal to 2, and 0, 1, 2, 3, 1. So basically, initially color coins 0, 0. So if we don't change our color, then we will have a -1, and if we do change our color, then we will again have -2 plus 1, which is -1. So let's just change our color, and then again if we don't change our color, we get a -1, and but if we change our color, still we get a -1. So since we see that there is a 1 coming up, so let's just choose not to change our color, -2, and then again we will not change our color and get -3, 1. So the answer for this test case will be 997. So basically what is happening is, let's say that initially it was 0, 0, and then basically let's say some colors were 1, 1, 1, and there were a lot of gaps. Basically here there were some numbers 2, 3, 4, 2, 6, 5, and then again 1, 1, 1. So basically if I by plus k minus k plus w, if I change my color to 1 here, basically coins, whatever coins I have, if I change my color to 1 here, what I'll do is I'll obviously go to the next and keep my color as 1, and then I'll go to the next and keep my color as 1. So now what happens is I have two options. I can stay at 1, or I can change my color to 2. So basically uh, uh, if I stay at 1, then all of these elements I know are not equal to 1, right? I know are not equal to 1. So if I stay at 1 and don't change my color, then all of these would be giving me minus W only, right? So -2, -3, all of these will be giving me minus W. So what I can do is, uh, if I'm deciding to stay on the color 1, then one thing I can do is I can straight away go to here and calculate my answer from here and add -2, -3, -4, -2, -6, -5 to that. This will be one one type of transition that I can do from this one, where I don't change any colors, right? And since I don't change any color, there will be another transition where somewhere in between I decide to change the color, right? That can also happen. So basically, but in that case, I don't need to actually know what the color is, right? Because I just need to know that if the color currently that I have is equal to what my color is or not. The only relevant information is that is the current color equal to the city color or not. If it is equal, then I'll simply add plus WI. If it is not equal, then I can maybe just take minus WI, or I can even take minus K plus WI. So basically these two transitions can happen, right? So two things, if I decide to stay at 1, then obviously all these elements are not equal to 1, so I'll go to here. And the other decision that I can make is I can go to 2. I can change my value to 2 and come here. So basically what I can do is uh, let me define some state here, because I kind of see the sub problem where I am getting my current answer from other states. So let's define a dp as I comma type, where type equal to 0 tells me that the color of my color is not equal to city color, and type equal to 1 tells me my color is not is equal to city color. Right. So let's look at the different cases. So let's say that I am calculating for dp of I comma 1. So what does that mean? So let's just start our indexing with the ith index, and this is n. And let's say that this has 1, 1, 2, 3, 4, 5, 1, 1, 2, 3. Right. So okay. So basically one type of transition can be uh, let's take this as 7. Let's take it not equal to 1. So one transition would be simply dp of I plus 1 comma 0 plus wi. So basically, since the color of my and the color of the city is same, right? So wi would definitely will be added to my answer. And I know that the next city, and I am assuming that the next city is has a different color than current city. So, and I am not changing the color, and I am not paying k coins for that. So the one of the transitions can be dp of I plus 1 comma 0 plus wi, which basically simply goes to the sub problem of this, where it is 7, 2, 3. This is I plus 1, and I only have the relevant information that my color is not equal to 7. I don't need any other information, because if I change my color, then my previous color does not matter. And if I don't change my color, so let's say that if I don't change my color, it will only matter when I arrive at this one. If I don't change my color till this one, it now things will start to matter, because because my color was 1 and I have arrived at this index, but the state tells me that my color is not equal to 1. So that basically uh, that will basically not let me get the correct answer, because here instead of plus wi, I will be getting minus wi coins. So so this is one problem, right? If I decide not to change the color in between any of these states, then this one will give me a problem. And if I decide to change the color in between any of these states, if I change color in between, then one is not a problem. This is one thing. And if I do not change color in between, then this will give me a value which is less than, or less than, actually less than the actual value, actual best value. So basically, because we have color equal to 1 here, since we did not change the color here, but we don't know it. We think that our color is not equal to 1 and that is bad for us. So basically, we need to handle this case, right? We need to handle this case. So what we can do is we can do another transition of dp of j comma 1 plus minus sum from I to j. I to actually j minus 1. Uh, just a second. I plus 1 to j minus 1. So basically now what is this? This is the case where we do not change color in between here. So what happens is we did not change color. So minus wi, minus wi, minus wi, minus wi, minus wi, and this is the index j. J is basically the next occurrence of the current color. So we can easily calculate j in the map. So I'll tell you guys how later. So let's just say that we somehow have this j every time. So j is basically the next occurrence of the current color, and we are saying that we need the answer for the case where we don't change the color in between this. So the sum of all these elements would be sum from I plus 1 till j minus 1. Since this is I plus 1 and this is j minus 1, so sum from I plus 1 till j minus 1, we can subtract that and we can now calculate the answer from j with comma 1, since we know that the current index and our color is same. So these two transitions, the maximum of these two transitions will give us the answer for the state dp of I comma 1. Now to calculate the dp of I comma 1, we are requiring dp of I comma 0 states as well. So let's see how can we calculate them. So dp of I comma 0, which means that the current color is not equal to the current index. Our color is not equal to the current city's color. So let's draw the diagram. So this is I, this is N. And our transitions can be, one is simply we will, since the color is not same, we will do minus wi plus dp of I plus 1 comma 0, right? And the other case is we can minus k plus wi. Basically we are changing our color to the current color, and that would be now plus. So basically now we will do the these two transitions. Now we will have to do these two transitions. So this plus maximum of dp I plus 1 comma 0 and dp j plus j comma 1 minus sum I plus 1 plus j minus 1 minus sum I plus 1 comma j minus 1. So basically again, since we are buying the color, then our color will become the same as the color on this city. So this will be very similar to the case dp I comma 1. But in just in dp I comma 1, also basically plus wi here also, since I forgot to add. So basically this is nothing but this case is nothing but dp I comma 1 minus w minus k, since we are just paying an extra k to get that color, and then from there this is same as dp I comma 1. So this is same as dp I comma 1 minus k. So this is basically how our transitions work. Uh, so this is how our transitions will work. And how can we find j? J can be found by creating a map of basically color to vector of indices with that color. And we can basically, in this map of color, we can take an upper bound, and that will give us the upper bound of the ith element. upper bound of I in which will be j. So this was the solution. And since there are two n different states for dp, and for each state there are two different transitions, so into 2, and we are having an extra log n because of map, so the total time complexity would be 4n log n, which is nothing but O of n log n. So I'll show you guys the code. So basically this is if type 1, then I do the transition dpi plus 1 comma 0, which is dpi plus 1 comma 0 plus wi. I have done it separately. Basically I have you guys will see temp is maximum of dpi plus 1 comma 0 and maximum of temp uh, minus sum plus dp of sum is basically nothing but prefix sum till I plus from I plus 1 till j minus 1. So basically this value is j. Upper bound of MC is the map. So upper bound in MC of color of I and upper bound of I will be j. So MC of C of I of IT will be the j. So prefix sum till j minus prefix sum till I will give us this value. And I am taking the max of temp again with minus sum plus dp of j comma 1. So minus sum plus dp of j comma 1, and then my answer would be temp 1 plus temp. So temp 1 was wi plus maximum of these two will be temp, and then answer is max of answer comma temp 1. Else if type is 0, then first transition will be minus wi plus dpi plus 1 comma 0. The next transition is nothing but exactly same as the last one, but I initialize with instead of wi I initialize with minus k plus wi. This is nothing but copy pasted from above, and then again answer is the maximum of these two transitions and return dp of I type equal to answer. So this is for memoization. This line was also for memoization, and dp of I equal to n return 0, basically obvious. So and then dp of 0 comma 1 will be the answer. Since initially since we are starting from the 0th index, and initially my color and the city's color are same, so since our color is also 0 in the beginning and c1 is also 0, so dp of 0 comma 1. And this is how we are creating that map. For each MC of I, we push back I in it. So we create the map, and PW is the prefix sum of W for creating that, for calculating that sum. So this was the solution for problem C. Let's move on to problem D. So perfect matching. Chef constructed a tree with n vertices using the following process. Generate a random array of size n minus 1 where 1 is less than equal to pi is less than equal to I. All possible arrays satisfying the constraints are equally likely. Create a tree with only one vertex labeled 1. For each I equal to 2, 3 till n, add a vertex labeled I to the tree connected with an edge to pi minus 1. Find the probability that this tree has a perfect matching. Output the probability modulo 998,244,353. Formally, it can be proven that the answer can be represented as P by Q. So, and that is, and a matching is a set of edges such that each vertex is adjacent to at most one edge. A graph is said to have a perfect matching if there is a matching such that each vertex is adjacent to exactly one edge. So t is less than 100 and n is less than equal to 10 to the power 4, and the sum of n overall test cases does not exceed 10 to the power 4. So the expected time complexity would be n square at max. So let's see now. Problem D. So basically, we need to create a tree where 2 will be connected to 1 and 3 will be connected to either of 1 or 2, and then 4 will be connected to either of 1, 2 and 3. 5 will be connected to either of 1, 2, 3, 4, and so on till n will be connected to either of 1, 2, 3 till n minus 1. So basically we can see that for each I equal to 2 till n, add a vertex and connect with an edge to pi minus 1, and pi minus 1 will be till I. So basically for 2 it will be connected till 1, for 3 it will be connected till vertex 2, for 4 it will be connected till vertex 3, and so on. So this is basically the possible pi values. P basically pi minus 1, I think I should say, and this is vertex. So basically we see that this tree is kind of an increasing tree, since 1 is connected to 2. This is always 1 is connected to 2, and then 3 will be connected from 1 to 2. So it will be like this or like this. So let's just take like this for now. Then 4 will be connected to 1, 2, 3 or 4. So let's take it like this. 5 will be connected to somewhere. So let's take it like this. So basically the value will increase from top to down. 1 then 5, 1 then 2 then 3, 1 then 2 then 4. So value increases. Similarly, for 6 it can be connected from anywhere between 1 to 6, right? So it can be here, it can be here, 7 can be here, 8 can be here, then 9 can be here. So basically value increase with depth. So we need to create trees like this, and we need to find the probability. So find the probability that this tree has a perfect matching. So now we need to know about what is a perfect matching. So basically the definition given from percent matching is a matching is a set of edges such that every vertex is adjacent to at most one edge. A graph is said to have a perfect matching if there is a matching such that each vertex is adjacent to exactly one edge. So basically, if in a tree we are possible actually it is possible to select some set of edges such that each vertex is adjacent to exactly one edge, then it is called a perfect matching. So basically, let me also take one example to explain this better. So let's take some tree like this, and this, and this. Okay. So basically, now we see that also let's take this as well. So if we select this edge, then 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 this vertex has one edge adjacent, this vertex also has only one adjacent, this vertex also has only one adjacent, this vertex also has only one adjacent, these two have only one adjacent, these two have only one adjacent, these two have only one adjacent, and these two have only one adjacent. So all the elements have only one adjacent edges, and so such a set of edge are possible. So basically this tree is said to have a perfect matching. Let's take another example of this. Let's take, so basically we'll take this edge, and then we will take this edge, then you will take this edge, and this element will be left over. So this element does not have any edge in adjacent to it, and all of the remaining have one edge as adjacent to them. So basically this is not a perfect matching. So don't think that a not perfect matching will only be in cases where the number of nodes are odd. It can also happen in even. Let me take an example. This, and this. So here we will have to take this edge, and then we cannot take any other edge, because then this element will have a double adjacent edges. So basically this is not a perfect matching. But obviously, in cases of odd number of vertices, it will always be not a perfect matching, because in each vertex there will be two edges. So the number of selected vertex into two would be the number of edges having one adjacent vertex, and hence that would mean the total number of vertex must be even. But since they are odd, there cannot be a perfect matching. So this is our first observation. In no arrangement is it possible to get a perfect matching. So this is our first observation. Now let's move on and try to solve the question. So up till now we have learned what the perfect matching is and what are the possible different pi minus 1 values for each vertex, and we saw that the values increase with depth. So this was also our observation. So now since we need to find the probability, right? So the most basic formula of probability is number of favorable events upon total events. So basically, in this case, the total number of different trees would be, since 2 has just one possible value of its parent, so into 1, then into 2, then into 3, till into n minus 1. So basically, total number of trees possible will be n minus 1 factorial, and total number of favorable events we need to calculate. So now instead of calculating the probability directly, we need to just calculate this number of favorable events, or the number of which is equal to number of perfect matching trees. Right. So let's move on and try to solve the question now. So basically, let's start, since we know that 1 is always connected to 2. We know this, right? This is the only piece of information that is fixed in the tree. So let's start here only. So basically, let's first assume that the total number of elements, the total number of vertices is even. Let's first try to solve for this case and let's see what happens, right? So 1 and 2 will always be connected, and in this case let the total number of elements be I only. So I is equal to total elements, and since they are even, so what will happen is basically now there appears to be two cases that we need to identify, that we need to solve for. So basically case 1, what might happen is 1 is here and 2 is here, and there is a subtree of 2, right? So in the subtree of 2 there are even number of elements. So basically, if in the subtree of 2 there are even number of elements, then we cannot select this edge as part of our matching. How? Basically because the number of elements in S is even, and if I select 1 and 2, then basically here there will be odd number of elements remaining, which will not be able to be a perfect matching. So 1 and 2 will not be selected together. So basically 1 will have other childs as well, which can be whatever. So let's say that here there are S elements, and here then there would be I minus S elements, and we know that this is not a part of our perfect matching. So what we can do is, we now have two sub problems. Since S is even, basically we assumed it to be even since we are solving for case 1 where the elements in subtree of 2 is even. So we see that a sub problem has arrived with elements S, and again a similar sub problem with elements I minus S. Since I was also even, then I minus 1 will also be even. So we need to solve for these two separate trees, right? They are totally separate and individual from each other, independent from each other, I mean, because this vertex does not mean anything. We are not taking it as a part of our perfect matching. So basically, in this case, the answer would be, let's define some function, since we are seeing that there are sub problems. So that is a very good hint for the problem being a DP problem. So let's for now just say this is f of I into f of I minus S, and we also need to multiply with the number of ways that number of different ways to select these S elements. So how many ways are there to select this as elements? So the total number of elements were I, and two elements we have fixed, 1 and 2. So I minus 2 elements are remaining to be distributed, and then we need to select S minus 1 elements because 2 is already fixed and total number of elements in its subtree is S. So we need to select S minus 1 element. So I minus 2 C S minus 1. So this is the number of perfect matchings in this case. Number of perfect matchings in this case. So now let's look at the case 2. So again 1 and 2 are connected, and now we are taking now we are saying that there will be a subtree like this, there will be a subtree like this. Now we are saying that the number of elements in 2 are odd. Here S is odd. Let me write it like this, odd number of elements. So what will happen in this case? So now since we know that 2 has odd number of elements in its subtree, so we will have to select this edge. We will always have to select this edge, because basically here there are odd number of elements. If I don't select this edge, then I will not be able to solve for this subtree, because there will be odd number of elements in that subtree. So I kind of will always have to select this edge. And then after I select this edge, now there will be some disjointed separate rooted trees here and some disjointed separate rooted trees here. So let's define the function. Again, let's use that function and say that again this as, since here there are s elements, right? S into f of I minus s. So for now, this s is odd, right? And I minus s is even. I minus s will also be odd since I is even. So we define, now we need to complete the definition of this function. So basically f of n is equal to, if n is odd, then answer to a tree with I elements after removing the root. So basically, after removing this 2, what will be the answer of the rest of the elements? And similarly, after removing this 1, what will be the answer of the rest of the elements? So f of s into f of I minus l will be that, I minus s would be that. And again, we can do I minus 2 c s minus 1 to choose the number of different combinations for s. And if n is even, answer to a tree with n elements. So this is normal answer to a tree with n elements, and this is answer to a tree with n elements after removing their root. So basically we have s elements and we will remove the root, and then the whatever the answer for this is will be the answer. So we need to find the values of fs, right? Currently we have found the values for when f of n is even. We have found the value of this. We have found two formula basically which came out to be the same for when even and odd, when s is even and odd. So basically f of n is equal to I minus 2 c s minus 1 f of s into f of I minus s for n to even. Actually f of I, let me erase this. Actually I, and so I here and I here. Now let's take uh, total number of vertices as odd. So So in this case, now let's see what will happen. So basically again, we will start there because we only know this information 1 and 2. So the total number of vertices are odd. So since the total number of vertices are odd, now for this basically we need the value of this, right? We need the value of this because we need to use this function. We need to find somehow the value of fs and fi minus s, right? They can be odd. So basically total vertices is odd after removing the root. So basically this was our tree and we removed the root 1. So now what will happen? This 2 will break and several other children will also break. So basically we can treat this as two separate problems. This 2 breaking out on its own and all these. We can create two different problems out of this. So basically, first of all of these that are breaking out must be even, must have even sizes of the subarrays. So even. So let's say that the size of the subarray of 2 has 2s elements. And here also all these must be even because only then they will have a solution. Because we have removed the root, and if these are not even, then they will not be able to form a perfect matching, hence 0. So basically these all must be even. So let's for now take the number of elements in 2s, and since these are all even, these will be all odd. So basically uh, so 2s. Now this problem, for this problem, the number of ways will be f of 2s. Since this is a simple problem, 2 as a root, the size of tree is 2s and number of ways, so this is simply f of 2s into, now this can be seen as f of I minus 2s. Since this is again a total number of vertices are odd and we are removing the root vertice, breaking it into different trees, so it becomes f of I minus 2s. And into the number of different combinations of 2s elements, so I minus 2c 2s minus 1. So basically this was for odd and this was for when I is even. So basically the answer to our question will be f of n for when n is even, and in cases where n is odd the answer would be 0. And to calculate f of n, we basically now have this recursion relation from I to smaller values, here also from I to smaller values. So basically we will implement exactly this and we will use binary exponentiation and modulo inversion to calculate the combinatrix in O of 1 time. So basically here the S can be from 1 till I and here the 2s can be from 1 till I. So basically these will be calculated in O of n loops, where basically I will have to sum for all different s, and so calculating for all f of 1 till f of n, and each calculation will take O of n, so O of n square solution. So this was it and I'll show you guys the code. So basically binary exponentiation, then a little combinatrix function, which is basically nothing but n factorial upon r factorial upon n minus r factorial. And this is just generating, pre-calculating the factorials and pre-calculating the invert factorials. So if n is odd, then simply see out 0. And then this dp is basically that function. So for dp1, it is 1 because if I have just this vertex and I remove it, then there is Nothing. So this is just one way. Only one way for this. After removing the root, there is only one way of distributing of perfect matching trees. So basically dp of 1 is 1. Then I'll calculate from 2 till n, and s is from I minus 1 till, basically from 1 till I minus 1. And for even I will only decrement with 1. For odd I will decrement with 2. Basically because in case of odd I have 2s here. So basically I will move like 4, 2 and then 0. 6, 4, 2, 0. So basically minus 2. I'll do minus 2 here. And in case of even, no need to do minus 2. So this. Then ways is nothing but dp of s into dp of I minus s. So dp of s into dp of I minus s, and here dp of 2s into dp of I minus 2s. So basically this, and then dp of I equal to dp of I plus ways into c I minus 2 cs minus 1. So I minus 2 cs minus 1 into ways, and then summing for all the s. Then see out dp upon total number of events, which is n minus 1 factorial. So dp of n upon n minus 1 factorial would be the answer. So that was it for the discussion. So I'll end the meeting. We just check. Hello. Okay. So thank you guys.